to start real quick since we are running a couple minutes behind. I just start with an acknowledgement to country. The University of Queensland acknowledges the traditional owners and their custodianship of the lands on which we meet here today. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognize their valuable contributions to Australian and global society. And I'll announce who is gonna talk about EcoPlots today. Thank you.
Thank you. Thank you for the opportunity. So I'm Siddeswara Guru, the program lead for the TERN data services and data platform. So we build a data infrastructure to manage all the data collected by TERN. So today I will give a talk on the EcoPlots. It is a data integration platform for the systematic site survey residents. So the talk
you need to use the mouse and click on the screen. Just click on the screen anywhere, and then the notification.
So I'll just provide a brief overview of what TERN is, which are on people in and then I talk about it. So TERN is a national collaborative research infrastructure. So the main aim of the TERN is to collect and publish the terrestrial ecosystem data. So we are funded by the Federal Government Department of Education. So we are one of the projects out of 23 which are funded under this scheme. So we focus on the terrestrial ecosystem. There are other projects which look at the marine, the biodiversity, the human population, etc. So we collect data at a different scale, from a continental scale using the remote sensing to the local scale at the institute sensors as well. So one of the things what we do predominantly is to do a site survey where typically it's 100 meter by 100 meter by 100 meter plot, and then we collect the vegetation and then the soil information that includes the specimen and then the samples as well. So we bring so I lead the data infrastructure team, so we bring all this data together and make it available. So today, I will just provide a talk on the EcoPlots to provide a bit of a rationale why we build it and then I provide a bit of a demo as well. It's easier to give a demo rather than the slides, so just to showcase how it works and then how you can get the data. Okay, so just to provide a bit of a context, the site-based systematic survey, this is widely used method to collect the observation at the site. So if this is a common practice that's used by every state government agencies, as well as a lot of researchers. So Queensland, if you take a Queensland as a thing, so there are around 18,000 sites across Queensland just to do the vegetation survey. And then they have another database called the WildMap, which are similar sites to do the fauna survey as well. So most of the things they do it as part of the surveillance side of the thing, just to look at the status of the thing. And then some they do as a repeated measures as well. If there is a huge impact on the environment, they go and do the imaging. So I think the common things, especially in the researcher's perspective, there are a lot of long-term ecological research network. They go and collect data for 30, 40 years and everything. I think the longest one run by the CSIRO, Tropical Transit, which goes from, I think, across the coast of the Queensland, they have the data for close to 80 years worth of data. So I think there's a massive researchers-driven data collection that happens. One of the main challenges is to bring them together. So everybody have their own data, their own terminology, and then it's very hard to bring this data together. Typically, if you want to use their data, first of all, they don't give. If they give you, they said that, okay, you need to put me as an author. By the time you understand, it's almost like 6 months of the thing. But it's really worth it because if they give you the data. So that is the bit of a challenge in this one. So, and then if you provide a bit of a context again, there is a generally with the site-based survey, they can create a site, then they do a visit, site visit, they call it, and then they make an observation as part of the site visit. So each of the projects use their own protocol to do the measurement. That's how the terminology, the definition, everything changes. So just to give an example, so the Queensland government, if you look at the site level, the average vegetation height, they take the 3 dominant species and then they average only for the 3 of the number. It is not like an entire average of the. We can't just generalize that as like an entire average, so that the meaning is very important what they use it. So a lot of this, because they do the repeated measurement, nobody would change the protocol, partly because they will just, all the previous data will go redundant if they just change the protocol kind of thing, because the time series is the very key for this one. So there is a lot of anomaly you need to understand before you use this test. So typically, so this is one of the, the Queensland government data set. This is how the database looks when they, where they store all their vegetation data sets. And then, generally, if you ask them, they provide bits and pieces of this schema. So this is from a biodiversity PDBS, South Australian biological database. This has got around, I think, 180 tables. Typically, if they give you this, it's very hard for anybody to pull that information and make that. Okay, so the major problem is, how to bring them together. So one of the challenges, most of these survey happen at the localized level. Because if the Queensland government is doing it, it's a very Queensland centric. If somebody is doing it at the Alpine region, it will be that centric as well. And then, to bring them data together to do the national synthesis, that is what exactly everybody wants, especially in this. So that is a bit of a challenge, even at the international level. That's a challenge. So how do we organize all this data so that it becomes like a comparable artifact so that you can use them? So that's it. Okay, so the challenge is the data integration, partly because some provide data in a CSV file, text file, some provide data in a database. There is a multiple terminologies that is used. And then there is no systematic way to exchange the data. There is no international national standard. For example, to exchange the biodiversity data, you have DAWINCO. At least that is a standard. Everybody uses it. So at least you know that how to represent them. Especially for the site-based systematic survey, there is no standard like that. So that is a bit of a challenging thing. So that is why we need to build that standard first to do anything, to do the data image. So that's what we do. So this is how overall application works. You have a lot of multiple sources. So we represent that into a common model. And then we ingest into the database, and then the application will be on top of it. So that is how we access it. So we use the ontology to represent the information model, partly because we conceptualize each of the things. And then ontology, the most of the data is represented in a graph. It's very easy to change the link between the node in a graph than dropping the entire table in a relation database if there is something wrong. So that is the main rationale behind why we use ontology, partly because now we don't know, there are a lot of unknowns here than the knowns thing. So we can't have build a very structured way looking at only just 2 or 3 data sets kind of a thing. So that is why this provides us a bit of a fair flexibility on changing the model if it's required. Okay, so how things work is we take a source data, we add a semantic means the meaning. So when I was telling all the types, differences kind of a thing, we add a meaning to each of the terminologies. So that the main integration point is so the user, when they access the data, they know what they are looking at. So every artifact in the data has got a meaning, then you can make an informed decision. So that is the idea. And then you integrate the data set and make that available. Okay, so just provide a bit of an overview of the information, but not too technical. So if you look at like a representation of how the site survey works, right? There is a site, you set up a site, you visit a site, and then you do some activity. So the activity is you do the sampling. So basically what you do is, you do the observation of the features of that site. Yeah? So the feature is like a real representation of the phenomena that is happening in a site. You do the observation of that. Yeah? Or you do some sampling representation as well. So for example, if you take like a most dominant species, you can take only one species and say, okay, that is a sample of the entire site. Okay, when you do the represent, you say that, okay, that I represent this one for the entire site. And then you do the intervention, sorry for the typo there. And sometimes you do the intervention as well, especially with pest eradication and all those things. You do the intervention and then do the measurement. So next year you go and you go and do the measurement of the impact of that intervention. So if you look at these things, these are the three activity broadly people do. So that is how we model the thing. Okay, they do go and do the observation, they do some sampling, and then they do some intervention. And then for each of those activities, they look at the feature of the thing. So for example, the feature of interest is like you are looking at an individual plant. Assume that you want to do the survey of every plant in that plot. Okay, so the individual plant is a feature. So assume that you are looking at the entire community-wise. Okay, I'm looking at only the number of count in the community of the species plant community. Then the community is the feature. So that is the feature of interest. And then for every observation, there is an observable property that is like called as a parameter, like a vegetation height is a thing. And then there is a procedure how that is measured. And then there is a result time when that was taken, and then unit of measurement. So in that way, so that is how it becomes integratable, partly because for every observation you made, you have a procedure how that is measured. Partly then you know that whether you can integrate that data with your analysis, because you know how the data is collected, what is the unit of measurement and everything. So just to provide that information. So that is what we call as semantics. So add the meaning to all the contextual information before you provide anything. So that is what we do. Okay. So just to provide a bit of a context again, so these are like a major components in site visit, and then in each of the site of the feature, you do the observation, or there is a sampling and intervention. For every observation, there is an observable property, there is a procedure, and then there is a time reserved. So all these things are represented by the control vocabulary, so that for example, here the ground cover litter, you know exactly what is the meaning of the ground cover litter, what they define as a ground cover litter. It can be as a count, it can be percentage, whatever. Yeah? And then what is the procedure. If it's a point and sub method, for example, what is the procedure that was used, when is the date result and then the unit of measurement. So that's why we represent that everything as a control vocabulary, so that you know the meaning of each of the things. So just to provide one of the examples, so this is in our TERN surveillance monitoring. So basically they go and do the soil profile, they dig a hole, based on the profile, they collect some information. So here they're looking at the feature of the soil profile, and then for every profile ID, there's an attribute, because they dig it from a 0 to 1 meter, every level kind of a thing. So that is like a depth range, sampling location, because generally from the plot, it's a bit outside that bit is just outside the thing. So you have a sampling, that is where you do the sampling location. And then you do the observation of that. So you get like a soil color, soil horizon, pH, everything is the observation based on that. Okay, so that's how they represent it. So this is one of the example. I will skip this just in interest of time. I'll store it strictly. It's 25 minutes kind of thing. Okay, so once we build this model, so we build a front end for the entire thing. So that we call it as an EcoPlot. So what it offers is that it provides an ability to search at the individual observation level. So for example, you can go and search at the depth, like give me for that site visit, for that pit, at the depth 0 to 10, what is the observation, for example, you can do that as well. So we provide a fair bit of a facet where you can search based on the regions. So based on the data set, what we have, and based on the feature type. So the feature type is very critical, partly because that is the harmonization point. So if there are two different survey protocol, what is the feature you are measuring? For example, if both are measuring the plant, individual plant, so that is the feature type. Okay, the procedure may different, at least the feature type is the same. Okay? So that is the absolute critical in this model where that is the harmonization point. So that is where the harmonization starts for us. Yeah. So for example, even at the normal level, okay, if both are strangers, we and somebody else in the room, we have never met, and then we are in some other country, we accidentally met. Oh, you are from Brisbane. Oh, you are from UQ. Suddenly, that is the harmonization point. Okay, so that is the we may be completely different, but that is the harmonization point. So the feature type is very critical. And then you can search based on the procedure, the parameter, the time range, what you want. So what we do is, you can do the search and then we package the data and then we provide in a baggage specification. So baggage specification was created by a California digital library purely for the data preservation. So one of the main thing about baggage is that it provides the data and metadata together. If you look at, for example, you ask somebody to provide you a data, they will send you a CSV file. You take 8 months to write a paper. The deadline is looming on it. Most likely you won't cite the paper. You might have used that one. You just put it, or somebody gave this data, I'll put a URL to that one because that doesn't count as a citation. So we put all the metadata and data together so that they will never miss it, kind of a thing. So that's what the baggage do. And then assume that you're writing a paper, and then that data set you have used, you want a DOI for that, you can go and meet a DOI as well as part of that one. So that will persist for the as long as TERN exists or as long as this EcoPlot exists. So I'll just provide a bit of a demo of the things we'll just show you. So people can see the browser?
No, can you do the screen? Yeah, nothing.
Okay, so this is the, so I'll just go to. Okay, so this is the home page of the portal. So if you go here, you can see a bit of a statistics of what we have, data set and everything, how many observations we have, where are the sites and everything, the home page. And then if you want to search for a data, you go here. Okay, it provides a bit of a high-level overview of what you can do with this one. You can share, don't show me this. You can just every time it shows this one. And then this provides a facet, what I was telling. So for example, you are very quick and you wanted to, look at only some. So these are all the parameters that is there in this one. You can, so this is the number of observations. So this one is the number of observations. So if you are looking at a files bar, for example, select this one and then show result, and then it updates the entire facet as well. So then it will show you which data set this come from. So this one is a 3-part savanna from a northern territory. This is a long-term, ecological long-term network data set, which is collected from, I think, early 80s. I think so, around 20 years worth of data set. And then you can even fine tune to all the regions and everything. And then you can look at what are the feature type it has selected. So basically it's a plant individual, so individual plant, 5-star. And then if you're happy with this data, and then you say the show results, so basically you will have each of this. So this is one of the feature type. So you can select a multiple feature type, it opens a new tab like this. So this is a plant individual, and you can go so it provides some more information about when it was visited and everything. So every URL it provides to this. Okay, so this is the attribute of the individual plant. So basically it has got a tree ID and then this stem ID as well. So the attribute of this one. And then, so this is the feature of interest. So if you want to know what it is, so you click on this one. It shows you now what is the definition of the plant individual, so that then you can make an informed decision. I don't know whether here it's slow or the website is slow, I'm not sure. And this is an observation, the fast car. So it will show you again, because that is a categorical value, it shows you what that value is. And then the other thing is that there's a method. So method is explained so that you can basically look at the method as well. Clicking on this one, you can look at the method. So once you get the data, you click on the data, assume that you're happy with this. It will ask you to, because by default, few of the things are added. You can ask additional attributes to be added as well. Assume that, I just wanted to this one, I proceed. And then if you don't have an account, so you need to log in to upload, because it doesn't provide you, we send you an email because it needs to package, it takes a couple of minutes. So we send an email, and then you log in, basically you log in using the AAF Google on the Commons. If you don't have an account with TERN, so it will redirect to the registration page, you just register. So basically if you log into the AAF, it checks whether you do have an account or not. If you don't have it, it goes to the registration page, you just register. It takes 5 minutes to get a value that your account has been created, then you can use it. Okay, so, and then it comes to I should have logged in before. Once I log in here, and then it comes to the My Download page, where it will show all the filters and everything. And then you can request the data, and then it pulls the data. So every time, so whatever is there, that is, it's just like a shopping cart page. It keeps track of all your downloads, how many years kind of thing. You can go and resubmit re-ask for the data set with the same query. So that is where you can mint a DOI as well. So there is a button where, assume that you use that data, you are writing a paper, you wanted to mint a DOI. There is a mint DOI button where you can go and then put up like a proper title, description, everything, and then it will mint a DOI. Once you mint a DOI, that will persist. So basically you will get an exact data what you have downloaded kind of thing. So otherwise the data, because people send a bit of a periodic data set, because some of the things may be wrong, they fix it and send it to us. So if you are downloaded today, after 6 months, we may not guarantee you that you will get an exact data, partly because our data may have changed, because the data providers have changed the data, they fixed the data, whatever. Yeah. If you mint a DOI, you make sure that that data always persists. So I don't know what is wrong. Live demo is always terrible. So that is what. So we have a fair number of data sets. So we have ingested the Queensland government data set, all our TERN data sets. And then now we are working with the South Australian data set as well. That is going to be like 40,000 plots with both flora and fauna. So we will be ingesting this that one very soon, in the next couple of months. So it is under review from them, so they're reviewing it. So we will ingest that one. So the main aim for this one is to make sure that this becomes like a platform for people to come and access on the systematic survey data set. Just in the interest of time, I didn't realize even in this one got so terrible. I will just share quickly the last slide so that you get all the information. Okay, so to conclude, so we built a bit of a data integration platform, building the information model to map the systematic survey data. So the same information model is used by the department to build the biodiversity data repository, Department of Climate Change, Environment, I don't know, so it's a federal government. So we are working with them as well to basically use the information model what we have built, so that they are using that in the mostly on the domain aspects of it to in their data repository as well. So in the future, so we are working on so TERN has got like more than 100,000 specimen samples. We are working on integrating that one to this as well. So in the future, you can see. So currently, it's a very observation centric. So in the future, you will have a samples. You can look at the samples what we have, and then the observations as well. So we will meet the IGSN. IGSN is like a DOI for the samples. We will meet IGSN for each of the samples and make that available. So I think nobody in Australia has met IGSN for example, the vegetation specimens. So we will be the first one to do that as well. So that we are currently working on. So we will put that in probably the first quarter of the next year. So these are some of the information. The information model is there. So the control vocabulary, so we build like a massive amount of the vocabularies, especially the parameters and everything, which a community can reuse. For example, on the plant height, whatever, there's like a massive amount of vocabularies we have built. I think from the vegetation perspective, because a lot of our data set of vegetation, it's massive amount is covered there. So I encourage people to look at it, and if it's useful, just use it. You can just download and use it. So you can see the EcoPlot there. So there is a documentation in EcoPlot as well, and then there is we have built like the API dashboard as well. So because if the facet is people think that it's cumbersome, you can just go and look at, okay, I want to access data. Especially if you are looking data set from one data source, you can say that, look, I want to access data from this region or from this data source with this feature type, and then it will just generate a code for you as well, the API, so that you can put it in your program to basically pull that data set. So even in that EcoPlot, when I'm doing the facet, there's an API button on the left hand side in the corner. If you click on that one, it will generate a code. You can select, I want in R, I want in Python. So whatever the selection you have done, it generates a code for you. You can use that same code to use it in your program. So only thing is that if you are using the API, so you need to have an API key from TERN. So you need to just generate that once and then keep it kind of thing. So the main reason we are doing it is like as an increase, we need to provide the metrics for who is using our infrastructure. That is the only reason we are asking this login kind of thing. So now the department has become very strict. So that is why we don't have any access, any more information about you, because the AAF we are using, UQ holds your information. We don't hold any of your information. Only thing is purely the metrics. Okay, this many people have used EcoPlot, this many downloads have happened. These are the metrics we need to give to the department. So that is why we do it. So these are some of the other things, TERN we built, and then that is useful. So hopefully in the near future, I will have an opportunity to talk to you guys about some of these and so on. I will stop there. Thank you very much.
Perfect, thanks, really interesting. Did anyone have any questions?
You started with one. Well, first, this is a great talk. Thank you. When you're receiving data from your data sources and mapping them onto the information model, is there like data validation, error checking that happens with that, or is it just finding the common columns?
No, we do the validation. We can't check for the authenticity of the data. For example, if somebody says that their data is in Queensland, we check whether it's in a Queensland boundary, for example. For example, if somebody says the vegetation height, that should be numeric, we check that should be numeric. We don't know if somebody says 100 meters, we can't say that is true or not because they tell us, but we definitely check it's a numeric. That kind of a validation we do. Next.
Yeah, sorry, Matt.
So this is a big biodiversity aggregator for systematic surveys. But the government, like Queensland, they are doing their surveys and putting it into here, be WildNet or BioNet, New South Wales, the other one. And then you pull directly from them.
Yeah, so they for Queensland, they provide a monthly upload to us. Because their database is big, so they hide a lot of their information because something is threatened species, all those things they don't want to share widely. And then it's a monthly feed we get from them. So then we ingest that.
So you have API connections to all the state level biodiversity aggregators?
No, I wouldn't say all, but definitely we have with Queensland and then South Australia. The others, we need to engage with them and have a conversation.
So right now, these massive data sets are 2 of the states. And it will likely grow
Yeah.
quite a lot.
Yeah. So what we are interested is, publishing a lot of the research-centric long-term data set. Partly because state government, at least you people would know that it has a lot of the researchers, especially long-term ecological network kind of a thing. Nobody has got a clue whether they have it kind of a thing. So we are very interested in engaging with them to make that data available. So what we wanted to make sure that this is like a bridge between the government data set and then the research data set. So until now, one end doesn't know the other. So there may be a lot of overlap, but nobody knows about it. So that is a fair bit of an engagement. Yeah. So that is why if you look at the 3-part Savannah, that is like a research data set. Jeremy Russell-Smith from CDU is the PI for that one. So we publish as part of that process. And so we are looking at desert ecology data set as well to publish that, to ingest that one in the future. And then we are in the conversation with the tropical data hub as well to publish some of the tropical data. It takes a fair bit of a time in the engagement and everything, so that is why it's pretty slow.
So it's a place that merges government data with the researchers' data.
Yeah.
And then standardizes it.
Yeah.
Do you then extract presence only data and send that to ALA?
So ALA, we have built an API. So ALA pull from the API. So they are interested only in the specimen-centric data set. So we build an API, they pull the data from that API, the EcoPlot API.
So any presences in the plots data on TERN, species presences would be able to be searched and found in ALA?
Yeah.
Cool.
Because if you look at the state government, ALA also go and ingest state government data as well. So they didn't want to duplicate. So whatever is not there, they will pull only that data.
And the BDR sounds like something very similar, but only for federal government data, is that right?
So BDR, yeah, BDR, I think currently how the BDR works is, it's very similar bit of like an ELA, but they are looking only in the federal government and with very specific use cases, the EPA, data sets and kind of thing. So predominantly that is a state government. So what we are planning to do is like a build a federated search between BDR and us, so that if somebody search at BDR, they search our platform as well, or vice versa, so that the people get the data. It doesn't mean that data has to move between the repository. It sits there, it sits with us, and people can make that search and pull the information.
Last one, so the BDR serves a very similar purpose. And it's new. What are the differences, like what data would, I guess the BDR, I can't give them my data, researchers can't get BDR data. Only government funded projects, merit projects don't BDR.
Yeah.
But that then goes, so TERN is a place where all data that is available to be made public can be made public.
Yes.
Okay. The complicated landscape.
Yeah.
Follow up to the last one. So I know in Europe, if you get funding from the European Research Council, you have to publish open access, because the idea is you take taxpayer money and it should be available to everyone. How is it in Australia? If I have a data set of like 20 years, it's taxpayer funded, do I have to give it to you or no? Or how is that?
I don't know how much time you have. It's a complicated thing. For example, a lot of the people who have collected data, at that time there was no policy. Assume that people are collecting data from 40 years. At that time, university didn't get a clue what they are doing. So now even they claim that they own the IP. I think now it becomes universities are very strict. You don't own anything, even if you have a PhD. University owns the IP. But all the previous, that's why it's a long-term data. Long-term data is a mess. There's a lot of gray area there. So that is a bit of a challenge. Yeah. But even if you look at the ARC and everything, they recommend that make it available, but nobody go and check. If you look at, for example, a lot of people say that they published data, they provide over 10 data points. Nobody go and check, and that is a useless data set. So that is a bit of a challenge.
It was a really interesting talk. I was just wondering, off the top of your head, if you could give any examples of how this data has been used for published research.
So what do you mean the publish?
So like people can go and get this and publish it. I was just wondering like what questions have people asked of this?
Yeah, so with the current data set, you can, for example, look at all the vegetation, like a community in Queensland, because the Queensland vegetation data has been ingested, kind of a thing, and we have a fair bit of a data set as well. You can look at those kind of a thing, and then the species like a diversity, and then the abundance. I think one of the researcher, she emailed me. So she was doing some for the federal government, some carbon neutral work or the net zero emission work. They were looking at like a baseline data set. So they could able to go to this one, pull up all the species in the Western Australia, what they have, just to show that, look at this is a baseline currently, we have it kind of a thing. So they were looking at more at the species level, they aggregate at the site level, and then they look at the other thing you can do is you can look at like a vegetation cover and everything based on the observation. So we calculate, so those are the very common use cases. We calculate them. If you go and look at it, we provide that vegetation. It is a derived data set. When we ingest the data, we calculate that, partly because that's a very common thing people use. Oh, how do I get this kind of thing? And the other thing what we do is also, people say that, people generally, when they're doing the analysis, they go to like a bioclim kind of a thing to look at like the temperature on the site at that time. So we pull that information and then provide that as well. So we use the ANU claim, we pull that information so that it's easier for you. You don't have to go to bioclim. So it's a ANU claim is more Australia centric, is much better than the bioclim. So we pull that information in that as well. So you can see the climate data set, that is not an observed data set, that is a derived data set. That's why if you go to the method, it will tell you that, okay, this is derived from the ANU claim model kind of thing.
Can I ask one follow-up question?
Sure.
Say if I had this project that I wanted to do and I wanted to look at diameter of trees in Queensland, is there a way that I would get taken to TERN site if I, for example, Google data on diameter of trees in Queensland? Would that take me to TERN, or would I have to go to TERN specifically to see if that data was available?
So I'm not sure whether it may take to one of the records, but it may not take you this one because we haven't indexed the diameter of breast, with
Yeah.
this one. But if you go there, there's a fair bit of a DBH as well.
Yeah.
And then it has got a biomass, tree level, site level biomass. It's a fair bit of the data set as well.
So would just like use, I was sorry, just sort of like trying to think of like, for researchers who maybe don't know that much about it,
Yeah.
or sort of wanna try and search it, that's, yeah.
So because if somebody says that, look, these are the products that is useful, we can create those products and then write up a metadata so that Google index that one.
Yeah.
You know what I mean? So if you say that, look, can you create a product of biomass and then that is up to date thing, it's very easy to create a product and then we write up a metadata so that it's discoverable from Google. And then you will just get one link and then you just download that.
Cool. Thanks. Few minutes, anyone has any other questions?
I had a quick question for you, and I'm not that familiar with this data, so maybe this is already available. Are you just using like large established data sets, or say, if you have a researcher at UQ that's doing this sort of site level sampling, can they give their, like, upload it onto the site or give it to TERN? Because I guess.
So we are interested in the bit of a time series data set
Yeah.
because it takes a fair bit of effort that's useful. It's like a 1 point, probably it's not useful that. If somebody says that, look, we are happy to publish the site level in the future, we'll provide you, we're very happy to work with them to make that integrate with that one.
Yeah, okay, so if it's like a time series.
Yeah,
like over
because that is a
years
more
or-
useful thing.
Yeah.
This one, so main intention is to provide that long-term time series data set, not
Yeah.
like a one-off kind of.
Yeah, just in one place where you can do those sort
Yeah,
of established baselines. Yeah. If anyone has long-term data and they'd like to upload it. Yeah, perfect. Any other questions? All right, no worries. We'll just thank you for doing it again.